require the use of BIM. Our definition of BIM is much, much wider than what the rest of the industry looks at as BIM. Most in the architectural engineering industry, and it's not a bad thing, BIM is being used for design and construction to create those design and construction documents, engineering documents. We look at it as managing information and then being able to use that for the life cycle. So we're trying to harvest information before it kind of gets locked up into a static CD or paper document. But yeah, I feel that it's still kind of the tip of the iceberg as far as the industry shifting. And I think the connection to energy is driving a lot of interest from the owner side because they're looking at, GSA for example, wants to have high-performing buildings. How do you measure if your design is going to be high-performing, and how do you track that information once the building is complete? And unless you're able to see it in a format such as this, it's going to be impossible to even make those calls or those decisions. So we're around the rest of the afternoon. We're presenting. There's a session at 3:30 that Mike and myself are going to be in. But we'll be here at the booth, and if anybody wants to actually try this hands-on, we have a live internet connection here, faster connection. It's not the open network here, so we can actually work live on this. One other point is that these files are extremely small. The transactions I'm making, when I move a room, I don't have to even know where that building is, the rest of the building. I only am looking at that floor, at that space. So it's a very small thing saying I'm moving the space. It's immediately sending it back to the server so it knows what's going on, versus having to download the whole thing. And then this is called a BIM model server. So a model server is not like an FTP site where you load the whole model. You basically have a database that says, I want to go look at the third floor of this building, and it serves you the third floor. You're looking only at the third floor, only at that space for the equipment. So again, a different kind of a concept, and because of that also, that's what also supports the real-time interaction. As I'm moving a piece of equipment, if I give somebody else access to that floor plan, they can actually see what's going on there. The open standards concept of this, I think is really exciting as we're working at other conferences like at EcoBuild. We actually demonstrate how we connect to other systems, to other vendors, to even other groups that might be somewhat competing with what we do. We don't see this as a competition. It's really about how do we connect to others. And the Building Smart Alliance, National Institute of Building Science, really supports, it's an open standard exchange way of connecting data about buildings from one tool to the next. And everything that we do is focused strictly on that. How do we make the data neutral enough to be able to move it? And that's why we use tools like Excel and CSV files. And in the background of this is MySQL, PHP, Apache, so it's a database running all this stuff. It's nothing magical about it. The magical part is about how all the pieces get connected and the user interface to be able to give a way for users to be able to work with the floor plans and edit data. We've trained participants who know nothing about the technology. Basically said, if you know how to use Expedia, you can at least start interacting with us. We've had our clients working with us where we just handed them a form and said, well, fill in this form of what your requirements are in a building, and push the button because you know what kind of spaces you want. So you can fill in the form, and then it basically pushes it back to the server. So this is an iPad interface that says create a BIM. You know, how many spaces do you want? What's the name of your building? How many square feet? Where is it located? You hit submit, it actually pushes it into our system, and it starts looking like the bubbles that I showed you earlier. It puts the spaces on the right floor, it puts the equipment in the right room, and then another engineer could come in and start saying, okay, now we're thinking of doing this. So you're starting to interact directly with the users that know, well, I need to have a conference room that fits 20 people, I need to have a projector in it, I need to have this kind of temperature in a room. It makes an easy way to interact and pull data into a format that can be read back into BIM or these other tools. So the real-time connection to energy is very, very exciting for us here at Connectivity Week. We first came here last year to demonstrate conceptually how that could work, and then we started hooking up with people that were here. And Mike Lavelle was one of the groups that helped us the last 6 months. We've been going pretty heavily at, how does this work, working at the workflows, creating an actual working system that we started to show to clients that are getting very excited about it, and we're looking to partner and work with others here at the conference to see where else we can take this. So, question again? Yeah, go ahead.
Yeah. I noticed that when that data, that data came up, when you drilled down into an air handler, it looked like it just started trending there. Where's the historical data?
That's collected separately on our server remotely. It's an option for a customer to do, but this presentation was real-time data, but yes, it's collected separately.
Okay.
And you can choose to collect it on your server if you like.
In fact, the historical data that I showed in Google Earth, we worked out and said, well, I want to have the real-time data, what that temperature is now, but I also want to collect the historical data every 15 minutes, and we store it on our server. That's how I was able to do the Google Earth thing. So I said, I don't want every 1 minute, we want it every 15 minutes, because that's the kind of analysis we want to do. Because as you can imagine, there's tons of data when you start getting into a lot of equipment, a lot of sensors. So it's more about what makes sense to view and what makes sense to store, and where do you store it. It could be stored on another server, it could be pushed over to our server. So you keep it kind of fluid like that, and then you make a decision what you want to see. And the development time gets drastically cut down because we kept it very simple as far as how we're exchanging data through the web services and XML and all these other open standard formats. So it's nothing, you don't need a rocket scientist to kind of figure out how to make the connection. We keep it as simple as possible, keep it very short, kind of modular, loosely coupled, and then you're able to kind of mash up a lot of different things. So in our other conferences, we had a similar demonstration with a group called Tokomo where they were doing cost estimating. So imagine another cost estimating system, another database that says, we're doing costs, we want quantities from your model. As you're doing the model, we don't care about how pretty it looks or what the layout is. We just want to know how many square feet of carpet are in this building. It's just a simple request that they get sent back and said, on the third floor, there's this much carpet, this much square footage, and say, okay, here's the cost for that. And you do that for the whole building, you start getting this kind of a real-time interaction. So our costing that's built into our system is very basic. It's kind of cost per square foot, kind of really rough numbers. If another group has more detailed cost estimates, we don't even have to know how they do it. We just need to know how to connect to them, and they're doing their cost. So with design build teams that we're working with, they have their own proprietary way of how they do their cost estimating. There's no reason for them to expose that to us. They just need to know quantities. So they use our system and their cost estimating database to create rapid, real-time what-if scenarios. And when they show that to owners, owners get really excited again because typically that takes a long time to do and it's not accurate.
What's the perceived, and I don't know much about asset management, what's the perceived value to an owner to know what his carpet costs are?
Well, there's many, what's the perceived value? Depends on who you are, what role you have in that process. If you're the owner, you might not care about the cost. You might just care about, well, how much is it going to cost me to maintain? When am I going to have to change this carpet? If you're the facility manager that's managing a piece of equipment, you just might want to know, well, where is that air handling unit? What room it's in? And where do I get that information? So all that I'm showing here, if you think of this, that can be built on the fly. If I'm creating a new application and all I want to know is, if I'm a carpet manufacturer, I only want to know carpet, then I don't care about the rest of the stuff, but I want to know quantity, I want to bid on that carpet. And these are the kind of discussions that we're having with product manufacturers. We want to start interacting with systems that give us an edge in being able to bid, for example. Obviously, a lot of this discussion is kind of future tense because the industry is not all there yet, but it's rapidly moving in that direction because it would be impossible to do otherwise. So I explained at the beginning that not every user is going to touch every part of the interface that I showed you today. We have some participants that all they do is work on the Excel file. They know a lot about how to program a building and say, well, a school district needs this much square footage, this much equipment, and they're very good at Excel. They know nothing about CAD or BIM, but they're very good at creating a list of equipment. That's very valuable data. Then we import that in, and it's like a delivery truck. It basically creates all the spaces and puts all the equipment in the right room, and then another user might open it up and say, okay, now let's lay it out and see if it makes sense. The owner said they wanted 20 workstations in this room, and they wanted a 2,000 square foot room. Is that going to fit? And there's many instances where that's not the case. So you start seeing what we call the train wrecks. We create a lot of train wrecks. We love train wrecks because we want to see them and then be able to react to them and get somebody else to give us their input. So for our Homeland Security projects, we're able to send a file like this to a security expert and say, we're thinking of putting a building here. Does it make sense to put this room on this side of the street? And they say, no, that's a threat because that's a high value room. It's close to the street. You have a standoff distance, so let's move it around. So we're able to react and say, okay, let's switch the building around. You have that discussion right there on the spot before it's too late, because typically, I mean, just across the whole design process is what's constantly happening is that there's decisions that are made that aren't caught for a day, a week, a month, or maybe never. They might end up on a construction site and have a bad decision that's under construction. They have to reverse it and do all kinds of things. So there's proof in the building industry that close to 50% of the decisions are made that are basically waste. Bad decisions that have to be reverse engineered, undone, and the construction, you stop the construction, all kinds of things happen, and that's because